Hi everyone. So previously in the previous video you have used Desmos and you have tried to understand how the amplitude, the angular frequency and the phase constant changes the shape of the graph, the characteristics of the graph, the shift of the graph. You learned that the amplitude will change the graph vertically, the angular frequency will compress or expand the graph like horizontally, and the phi will shift the graph like this. So knowing how all these things relates to each other, let's try to apply what we've learned in a question where we plot this equation. To plot this equation, what we will apply what we have learned just now. So I'll just draw the axis here for now so that it's easier for us to do the plotting. This is my way of drawing. Feel free to explore in YouTube or in internet. There's plenty of people trying to explain how to draw graph with phase constant, and there's many ways of doing it. This is just my personal way of doing it. Feel free to explore others. So before I start the thing, let's just mention that this x is in meter, whereas this time is in second. Just like most of the question. So let's start then by extracting information from the equation itself. So extracting, we compare it with the general equation, the formula for this equation. X equals to a sine omega t plus phi. This is the general equation. So by comparing it, we can see that the amplitude is equals to 3 meter. Then we can also see that the omega, which is the angular frequency, it equals to pi unit radian per second. Last thing we have here is phi is equals to pi over 4 radian. How do you know it's radian? See, omega times t, omega is radian per second, t is second, radian per second times second, boom, you get radian. Then you know from your dimensional analysis that when you add up one thing with another, the unit must be the same, it must be consistent. So if omega t has the unit of radian, phi will have the unit of radian as well. So just to be very clear, you might not know how am I pronouncing it. It's phi. So knowing that, we can probably start to plot, sketch the equation, sketch the graph. But before we start to draw the actual one, let's just try to cover it up, the phi. Just cover the phi and just plot it the usual way. That's how I usually do it. To plot the usual way, I think probably all of you or many of you here know how to do it. You just draw a sine curve. After drawing your sine curve, you have an amplitude. So now it's just a matter of labeling it. Then you have your 3 meter. Down, you have your -3. To know what's the period that you need to label here, period omega is equals to 2 pi over capital T. Therefore, T is equals to 2 pi divided by omega. So 2 pi divided by the pi that we have here, omega, divided by pi. Then what you get is 2 seconds. So the period is 2 seconds. Label as 2. So if there's no phi, this is the end. We have finished plotting, we have finished sketching our graph, our xt graph. Now we have to accommodate for the phi. We cannot ignore there's a phi there. So we learn from Desmos, if it's a positive phi, you shift the graph to the left. If it's a negative phi, you shift the graph to the right. We'll be doing that. But instead of shifting the graph, how about we try to shift the axis instead? Why do I say so? If you are drawing this on paper, shifting the graph means you have to erase the blue line, then you shift the graph to the left, then you redraw it like this. Well, you have to erase a lot of stuff and you have to redraw a lot of stuff. How about instead of shifting the graph to the left, we shift the axis to the right. So you can just move this axis to the right. So it's equivalent to shifting the graph to the left. If you think of this is the graph, this is the axis, instead of shifting the graph to the left, what can I do is I can shift the axis to the right. You will still carry the same meaning. Okay, so let's do that. The problem is how much should you shift? So this is a thing which might be new to you. So how much should you shift? How I do it is I find how much of an complete oscillation do I need to shift. How do I do that? I know one complete oscillation is 2 pi. So I take pi over 4, divide by 2 pi. Then my answer is 1 over 8. So means by I have to shift 1 over 8 of a complete oscillation. Okay, I have to shift 1 over 8 of a complete oscillation. So how much is 1 over 8 of a complete oscillation? This is a complete oscillation. 0, 1. Okay, one complete oscillation is here. Half of a complete oscillation is probably here. 1/4 of a complete oscillation is here. 1/8 of a complete oscillation will be somewhere here. So we have to chop the graph around here. So that will be around here maybe. Okay, if you see on the graph, it's around here. So means by I have to bring the axis, the y-axis there, the displacement axis, I have to shift it to the right until it hits this purple point that I point just now. So I shift the axis to the right. This requires some delicate hands. Okay, so this is my axis being shifted to the right. So what I can do now is I can erase the previous stuff. Okay, I should be erasing this small chunk of blue color here because I chop it off. I should remove it, but yeah, PowerPoint doesn't support cutting it a little bit, so you get what I mean. So I label 3 here, -3 here, still the same thing. But the thing that I need to change, that really need to change, is this thing here. I've moved my graph. Oops. I have moved my graph for this much. Okay, let's call it amount time t. Okay, means by my time here should be cut by the same amount of time as well, because I shift by the amount t. So the 2 here I need to cut by an amount t as well. Okay, so how do I find the amount of t? What I do is I take, this is another new thing, so probably another color. What you do is you take phi divide by omega. Phi is pi over 4 divided by omega, which is pi, means by you have to go by 1/4. Okay, so this is the time that I need to cut from 2 seconds, 1/4 seconds. Okay, if you're not sure unit, this is radian, this is radian per second, so you get second as your unit. Okay, if you want to visualize it, this is 0, then this is 2 seconds, so this is my period is here. Okay, so center it will be 1 second, half of it will be 0.5 seconds, so this one should be 0.25 seconds, which is exactly the same as 1/4. So 2 minus 1/4, what will you get? Okay, you don't need to write this. I write this just for the sake of being clear. 2 minus 1/4 here, then it will be 7/4. Okay, If you wish to label what's on the back, that's good as well. So I can label this as negative 1/4. Then I label here as 0. Okay, so if you want to be even more extra clear, then you can do something like this. Then you can say this is the period which is equals to 2 seconds. Okay, so that's it. That's how I shift a graph. In this case, I shift the graph to the left, or in other words, I shift the axis to the right. How do I determine how much do I need to shift? I determine it using this thing here. I divide the phase constant divide by 2 pi. By dividing by 2 pi, I know how much of a complete oscillation do I need to move. So I know it's 1/8. So I move 1/8 of a complete oscillation. How do I know how much should I change here for the time? I take phi divided by omega, then this is the time that I need to change. Okay, so I minus it out because I shift the graph to the left. So I minus it out. So I label all the necessary things, and this is my displacement time graph with phase constant. So I hope from this video you are able to know how to sketch a graph with phase constant. So that's all from me. Thank you very much.